Stephen, thanks so much for having me and for inviting me. I'm feel honored and humbled to be here and being part of this, and also have to go first. So, which may be, is this too loud? Okay. So, which can be a blessing and a curse at the same time. What I would like to do is to first remind ourselves, although we're all here talking and working in AR and VR, what it is that we are actually talking about, and then pick out of the various projects that we are running in my group, one that actually nicely demonstrates the value that immersive experience can add to learning and learning outcomes. So immersive technologies, or XR, are often organized a continuum, so the virtuality continuum, where we have from reality to going to full virtual reality, and everything in between is often referred to as mixed reality, which certainly is becoming one of the biggest new topics after the VR hype. The key concepts that combines and binds all of these together are the aspect of immersion. And this is really the important part where, in all honesty, we actually don't know exactly what it actually does, because it now allows us to be part of a representation in contrast to look at a representation. And this is the fundamental difference that we have available now, with the technology being at a level where we can step into the present, into the representation of the real world, of the past, of the future. And what this does exactly to how we learn is, to a large extent, an unanswered question. So the immersive part then affords this sense of presence. So in sort of using an immersive technology, other than technologies that we just look at, we have this ability to be present at a certain place. And again, it can be a different place on Earth, it can be in the past, or it can be in the future. And these are now possibilities that we only just start to explore. What this allows us to do also is that we can take perspectives that are otherwise not available to us. So for the slightly older generation, you may remember the Fantastic Voyage, the younger generation, Ant-Man. So we can now, and this is then coming to the next slide, as an embodied experience, see what an ant sees. We can be part of a process that operates at the cellular level as an actual observer, not by looking through, for example, a microscope. Whether this has a positive effect on learning, to a large extent, as I said, we don't know. But this is the possibilities that we now have that really are sort of the nature and the core of the transformative nature of immersive experiences. One thing also, and this is then the final side, so promise and potential of XR. So we essentially are changing paradigms. So from talking about sort of the old communication paradigms, we talked largely about information, we're actually talking about that it's much, much deeper, much, much more human. It's at the level of how we feel about a place, how we understand it with our bodily senses. And this is what we can use to our advantage, but we still need to have a lot more empirical data to separate what may be sort of the buzz, or whether we can say we just have some dancing bears that are waving at us. Okay. Yes. One thing, especially from perspective of creating the content, that's also important, is to look at the developments that are working in parallel, again, largely spurred actually by the autonomous car industry, that any kind of environmental sensing technology is also becoming drastically more accessible. So in my own field, so geospatial sciences, if I look at the cost for LiDAR equipment and how that came down to actually being available in essentially any lab, is something that we see across the board for any kind of environmental sensing. So we develop workflows, whether this is 360-degree cameras, LiDAR, modeling environment, but also databases, such as OpenStreetMap, such as ecological output of ecological models, that we now can translate with platforms such as CityEngine, Unity, Unreal, into immersive experience. And these workflows also become drastically more efficient so that we can actually create content that we then would like to assess and access in immersive experiences. So I have two examples that I would like to briefly talk in more detail about. They're coming largely from the geosciences. We're not exclusively working with geosciences, but we have a number of projects that we are developing with people there. The first one is kind of a pet project. It's actually an undergraduate, or started as an undergraduate student project. This is the Penn State obelisk. It's actually a learning tool that warped space and time in 1896. So Magnus Ilseng was a professor of engineering at that point in time. He sent one of his students, probably on a bicycle, across Penn State, across Pennsylvania, to collect stones from all across Pennsylvania. The stones then are ordered so chronologically, according to their geological times. And they were also meant to give people access to information such as what the stone actually would look like in 10 years, in 20 years after it was exposed to the elements. These days, no one knows what the obelisk actually is about at Penn State. So people pass by, they see, yeah, this big stone thing, but what on earth it is, no one knows. So what we did is we created a 3D model of it using structure from motion mapping. We had a database for the 281 stones that comprised the obelisk, and we created an interactive augmented reality app. Not sure. Is it starting? Yeah, thank you. So this is it's actually an older version where we use augmented reality, so you can, in this case, place the stone or the obelisk in your living room. You have an interactive 3D model. You can walk around the model, but then you can also interactively select every individual stone, which we will do in a second. Oh, yeah, you can scale it, so you can actually see what the obelisk, for example, looks like in sort of a one-to-one scale, which again is one of the things that immersive technologies afford you to do. You get information from all the different stones. You get the map where the stone is actually excavated from. Then if you click on the map, you can actually dive into a 360 image and see, oh, okay, this is where the stone is actually coming from. So, and this is what this technology allows us to do. And again, the nice thing here is that in 1896, people already thought about, hey, we need to bring this together in one location. We need to have a warping of space and time and use this as a learning tool. And now we can use immersive technologies to kind of warp space and time even more. Okay. The second, thanks. So the second part that I want to talk a little bit more in depth about is a study that we completed last fall, where the paper is just submitted. So if you're interested, I'm happy to share that with you as well. And this is on the empirical evaluation of immersive virtual field trips. And admittedly, I actually have a hard time with my geosciences colleagues to convince them that using a virtual field trip instead of sending students out to the actual field trip is something that is valuable, maybe even more value in certain aspects than the actual field trip. So there's a nice story that came out in the news about a professor in Vienna who is going around licking stones. So he's a geoscientist. And he's testing the weathering of stones in this way. So I'm the first one to admit that there are certain parts that you really only want to do in the physical reality and not in virtual reality. But given everything that I said before, I truly believe that we can actually give people access to information in an immersive experience that is actually not possible in the physical world. In this case, though, we basically replicated an actual field trip. So that was kind of a starting point. We call this a basic virtual reality field trip in comparison to plus or advanced versions of that. So what we did is, so this is just a satellite image of the outcrop. This is kind of the perspective. So this is what students in an introductory geosciences class are taken to. They're in small groups of 20 people, and then they work in teams. We replicated this field site using a number of different technologies. So basically, starting with 360-degree images, because that's the easiest way to collect information for immersive experiences at locations, and then implemented Google Street View-like navigation between the different images. We then had in the images interactive aspects that allowed for accessing more information. 360-degree images have a resolution problem, and so we took DSLR camera images, for example, to show students' grain size in more detail. And then we also complemented the information that they were accessing with information that they had either in their textbooks or in their lab manual, field manuals. For certain parts of the outcrop, we used structure from motion mapping to create an actual 3D model to be able to replicate the activities that students perform while they're at the field site. So in this case, they are recording the stratigraphy of this Reedsville Bald Eagle outcrop. So we just implemented a very basic way of measuring the thickness of the layers of the stratigraphy, and then recorded so that the students were able to take a record of their activities home with them. So and this is what came out. So this was what we were extremely surprised at, because the baseline for us was we didn't want to mess the students up. We didn't want to mess with their grades, so they shouldn't have like worse grades going into the field compared to going into the virtual field trip. So we split the class up into two groups. Half of them went into the field trip, and half of them went into the lab. So this is their lab score, which shows that they had the participants in the virtual field trip, so VFT, had actually statistically significant better lab grades than the actual field trip participants. What exactly contributed to that, I don't know. So there's a lot of factors that we're starting to tease apart now. We're actually running a follow-up study with field observations now. But the fact that they actually perform better was something that is very unique in these kinds of experiences. If you compare it to the virtual field trip that we have seen for a long time, administered, for example, through desktop displays, so to any desktop screen. To continue with that, the students also had self-assessed significantly higher learning experience. So they said that, yes, I learned a lot from this trip. They were happy to do the field trip again. And then we had a composite score for overall enjoyment, and that was higher as well. So on the student side, somewhat different from what the faculty think about the virtual field trip, there's a lot of excitement about being able to access field site virtually compared to actually going out into the field site. So this is just a first experiment that we ran, but we're very excited about the possibilities and now being able to kind of tease apart what it actually is that contributed to this learning. Again, we started with what we call a basic virtual field trip, replicating essentially what people do at the field site. One of the problems that we have now for the lab score, so 22 is actually the maximum. So they are maxed out already. So we are thinking now of ways of how can we actually show that if we give them an advanced field trip, for example, giving them overview perspective, or going to a full-fledged virtual model where they can, for example, look under the hood. How can we actually show that this even further enhances their learning? Okay. So with that, some brief conclusions. So immersive technologies are certainly disruptive in the learning field as they are becoming accessible as a mass medium. So this is I think the difference that we see now compared to the 30 plus years of research on immersive technologies that we have seen in the past. We are in the position to create embodied experience for essentially any place, but also any time and at any scale. So this is really something that has been thought about in certain ways, but it's really what makes the technology that we are seeing now these days new and exciting. And then all sciences, everything from the geosciences to engineering, with inherent 3D content, we'll see a drastic shift in doing both research or doing research, education, and outreach. But then, as I said, we need, with the new wave of immersive technologies that we see, a lot more empirical foundations of what is it actually that works. And Stephen is very nicely organizing and leading us this way with many others to sort of come together and to work on these foundations. So, thank you.